All right, we are moving on to lessons 10 and 11, and today we're going to do, we're going to start something new that I can pretty much guarantee that none of you have talked about before, and that is a new number system, different from our traditional number system known as the imaginary numbers. So really our traditional number system that you have been dealing with since you started learning math in elementary school is known as the real numbers. And that's our traditional real number system. And the one thing that we've always learned about the real numbers is that in that number system, you cannot square root a negative. Whenever we end up having a square root of negative, we say there's no real solution. So to help with that, there was a creation known as the imaginary numbers. Now, before anybody asks, imaginary numbers does not mean they're fake numbers. That's just what they called them. They could have called them red numbers or blue numbers. They just happened to call them imaginary numbers. So in this new imaginary number system, it is possible to square root a negative, something totally different than what we're used to in the traditional real number system. So this imaginary number system was invented in order to give a negative square roots a value. And some interesting things happen with that. So what they did was that they denoted the variable I short for imaginary, and the variable I is going to be equal to the square root of -1. And if I is equal to the square root of -1, then I squared is equal to -1. Okay, so the entire imaginary number system is based off of those two facts, that the variable I is equal to the square root of -1, and I squared is equal to -1. So essentially what that means is that when we have negative square roots, we'll treat them in the imaginary number system like they were positive square roots, except we tack on an I at the end. So for example, this first example I have here, the square root of -1, if it were the square root of +1, we would say that the answer is positive and -1. Well, in the imaginary number system, the square root of -1 is positive and negative I. Okay, the square root of -4. Okay, if we were in the real number system and we were doing the square root of +4, the square root of 4, we would say that the answer is plus and minus 2. But in the imaginary number system, the square root of -4 will be plus and minus 2i. Same thing with the square root of -9. If it were the square root of 9, we would say that the answer is plus and minus, positive and -3. In the imaginary number system, the square root of -9 is positive and -3i. So essentially, that's what happens in the imaginary number system. We can now take negative square roots and we can treat them as if they were positive square roots, except we tack on an I at the end. Okay, that is our imaginary number system. And now, as sort of an offshoot of the imaginary numbers, we have something called a complex numbers. And the complex numbers, as it says here, is a combo of a real number and an imaginary number. So the example I gave here is the complex number 3 plus 4i. In this particular case, the real number portion of the number is 3, and the imaginary number portion is 4i. If you put it together, we call it a complex number. So we are going to be doing a lot of stuff with imaginary numbers and complex numbers over the next few days. Actually, for the next bit of time here. So let's take a look at the examples just to see some of the stuff that we'll be doing today with imaginary numbers. Okay, so let's take a look at number 1 here. Write the following as imaginary numbers using I. Number 1, the square root of negative 100. So like I said before, we can treat, because we know about imaginary numbers now, we can treat negative square roots as if they were positive square roots, except we would tack on an I at the end. So based on these examples over here, okay, the square root of, if it were the square root of negative 100, we would say that the answer is positive and negative 10. But because it's the square root of negative 100, the only difference is the answer is now positive and negative 10i. Okay, same thing with number 2. If it were the square root of positive 144, we would say that the answer is positive and negative 12. Well, now we're going to say the answer is positive and negative 12i. And that is literally it. Okay. Number 3 through 6, solve the following equations. Notice they're very similar. 3 and 5 are very similar, and 4 and 6 are very similar. So if I take a look at number 3, for example, x squared equals 25. If I was going to solve that, I would, because of the squared, I would take the square root of both sides, and squaring and square rooting are opposites of each other. That would cancel, and I would say that the answer is x equals positive and negative 5, right? Because 5 squared is 25, and negative 5 squared is also 25. Similarly, if I was going to do number 4, I could take the square root of both sides to get rid of the squared on the left-hand side. The difference here would be that this 26 is not a perfect square, so I would just leave it. I would just leave it as a square root and say that x is equal to positive and negative square root of 26. Instead of writing the decimal, I would just say x is equal to positive and negative square root of 26, since 26 is not a perfect square. Okay, so that's how we would treat it if we were in the real number system. Now, if I was to look at number 5, okay, and I was to solve it the same way, so take the square root of both sides in order to get rid of the squared here, I would end up with x equals, well, now I would have the square root of negative 25. Now, if we were in the real number system, we would say that that has no solution. It has no real number solution. But because we know about imaginary numbers now, we can now say that the answer, instead of being positive and negative 5 like it is in number 3, we can say that the answer is positive and negative 5i. So x equals positive and negative 5i in number 5. Same thing with number 6. I can take the square root of both sides, okay, in order to get rid of the squared. Okay, but instead of saying positive and negative square root of 26, I can now say positive and negative square root of 26i. Okay, so moral of the story. If you're taking this first, now that we know about imaginary numbers, when you take the square root of a negative number, you take the square root like as if it were positive, but you tack on an I at the end. So square root of 25 is plus and minus 5. Square root of negative 25 is plus and minus 5i. If it's not a perfect square, like 26, we would leave it as plus and minus square root of 26. If it was a square root of negative 26, we say plus and minus, we make it positive, plus and minus square root of 26, tack on an I at the end. One thing I will say is notice that the I here is not underneath the square root. Okay? So when you do that, the I cannot be underneath the square root. It's got to be outside the square root. Okay? So we treat it the same way. Only difference is we tack on an I at the end. Okay? That is it for this second section here. Solve the following equations. Last kind of basic thing with imaginary numbers is we're going to look at number 3, number 7, and number 8, where we simplify, where we have imaginary numbers and we square them. What happens if I take an imaginary number and I square it? Okay. So, for example, number 7, if I want to take 3i and square it, we know that to square something, regardless of the number system we use, means to take that something and multiply it by itself. So 3i squared means 3i times 3i. And 8i squared means 8i times 8i. And if I were to simplify that, 3 times 3 is 9, and I times I is I squared. Same thing in number 8. 8 times 8 is 64, and I times I is I squared. And if we were dealing with a normal variable, like if this were 3x squared or 8x squared, we would be done here. But because we're dealing with imaginary numbers, let me go back to the lesson notes for a second. Okay, the entire imaginary number system is based off of these two facts here. That I is equal to the square root of -1, and the more important one is that I squared is equal to -1. So when we simplify, we have to use the fact that I squared equals -1. So when I simplify that, what that means is that 9i squared is really 9 times -1. And 64i squared is really 64 times -1. So 9 times -1 is -9, and 64 times -1 is -64. So it turns out, what happens if I take an imaginary number and I square it? Well, if I take an imaginary number and I square it, I actually end up with a real number, right? I end up with a regular -9, -64. There's no I in it, okay? So it's really important when you end up with I squared in your answer, you have to use the fact that I squared is equal to -1 in order to simplify it as much as possible. So your cool down today, your cool down for lessons 10 and 11 will be a bunch of examples just like the ones I did. So the first couple of examples will be like number 1 and number 2. Okay, then there'll be a couple of examples like 3, 4, 5, and 6, and then there'll be another example like 7 and 8. So as long as you wrote down these examples and you followed along, you should be able to do the cool down for lesson 10 and 11. And that is it for today's lesson.